Hello dear viewers, let's study about periodic properties of the elements in periodic table. I hope that you are having good health and doing great. So you know that the periodic properties of elements in the periodic table depends on some issues, and definitely this is very interesting and very important also to understand why these properties are called the periodic properties of elements and why these elements the properties of elements gradually change with their corresponding periods and groups, and then you understand that why it behaves like that, because you know that the proton numbers or the atomic numbers of electrons are very specific. Like sodium, the atomic number of sodium is 11, so it has 11 protons and 11 electrons. In the nucleus there are 11 protons, and in the shells there are 11 electrons. So each and every elements placed in this periodic table, they have specific number of protons and specific number of electrons. So now why these properties are called the periodic properties? So at first the definition of periodic properties is those properties of elements is gradually changing according to their periods and groups. These are called the periodic properties. And then these 6 periodic properties we need to understand. There are a lot, but among them these are very important. But if you say that what are the more importance in this, I will say that these 3, 4, 5, 6, these 4 the 4 periodic properties is very important to understand, because students of English versions and even O-level or even cadet college students, you know that the questions regarding these 4 properties is very common in the test paper or also in your question paper. So now think that what is the metallic property, what is non-metallic property, and then atomic radius. Whenever you understand the changes of atomic radius into this periodic table, then these 3 will be very easy to understand. So if you think that these 3 properties seems tough to think for you, so I hope that after this class you won't be having a trouble to think about this, why these 3 properties is a periodic properties. Let's talk about it first. So now you see this is the modern periodic table. So if you see the number of periods in the periodic table, we know that we have 7 periods and 18 groups in the periodic table. So you see the metallic property. So the metallic property, what is this? What is metal? Actually those elements are glossy and they produce metallic sound when they struck, and even they are the good conductor of heat and electricity. We call them metal. But in modern definition, those elements are more prone to donate electrons or more prone to be the cations, I mean the positive ions. They are called metals. Like here lithium. So if lithium donate electron, then it become a positive ion. If sodium donate 1 electron, then it become positive ion. And similarly, when potassium donate electron, it become potassium ion. So all these are positive ion. That means these are the cations. So how we can think that those elements of a group, like if you see that in the first group, these are all metal, these are all alkaline metal. If you see in group number 2, these are all alkaline earth metal. And you know it, in my previous class I already explained that the special names of groups. So these are the metal, this is also metal. But you see here till aluminium. Aluminium also can donate 3 electrons and it can be aluminium 3+. But if you see silicon, I'm just talking about the period number 3. If you see the silicon behave like metal and also non-metal, and that is why it's called the submetal. But if you go more right, then you will find phosphorus, sulfur, chlorine. These are non-metal. So the metallic property and non-metallic property is a periodic property, because if you go from left to right of a periodic table, then you will find that metal to non-metal. If you come to leftmost, then you will find the metal, and if you go left, then you will find non-metal. Who's a non-metal? Those non-metals are actually, they are more prone to accept electrons. And then suppose you see fluorine is more prone to accept electron, and it will become the negative ion. Chlorine is more prone to accept electrons and will become negative ions. But they cannot donate electron, because group number 1, because they are group number 1, in the outermost shell of atom of all elements, they are bearing 1 electrons. And in group 2, in all metals of the outermost electron, they will have only 2 electrons. So group 1 will donate 1 electron, and it becomes 1 single cations. So lithium plus, sodium plus, potassium plus. If you see about magnesium, calcium, strontium, barium and radium, they can donate 2 electrons and they become also positive ions. Like calcium 2 plus, like calcium will donate 2 electrons, it will produce 2 plus. In case of magnesium, it will produce 2 electrons, it becomes 2 plus. So it means that donating electron is the properties of metal, and accepting electrons is the properties of non-metal. So simply speaking, that if you go from right to left, then you will find non-metal, and that is why these metallic properties and the non-metallic properties are the periodic properties of elements. So I hope you understand that group 1 will donate 1 electrons, group 2 will donate 2 electrons, group 3 can donate 3 electrons, but in group 4, like silicon, if you see that it has behave like metals and non-metals, so it is submetals, and those are submetals. They are actually in between the metallic properties and the non-metallic properties. But if you go further in right groups, like group number 15, 16 and 17, you will have the non-metal. So I hope you understand the metallic properties and the non-metallic properties of elements. Now you see the most interesting character and most interesting atomic periodic properties of elements, which is atomic mass or atomic radii, which is called atomic radius. And of course I will explain these 3 later on, because I want to explain you more about this atomic radii, which is very common in a question paper. Why atomic radii or atomic radius or size of the atom is periodic properties? Because if you go from left to right, if you go of any periods, if you go from left to right with corresponding periods, then you find that atomic radii is decreasing. And if you go from upwards to downwards of any group, then the size of the atom or atomic radii will increase. Why? You just think one thing, that if the atomic radii is a periodic properties, if you go from left to right, then the atomic radii or atomic radius or size of atom will decrease. But if you go from upwards to downwards, then atomic radii will increase. Why this will happen? Now think about it. Suppose about sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Because this is very common, explaining the 3rd period, and this is very true also for 4th, 2nd and 5th period. But if you see that sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Suppose you know that all these 8 elements are in number 3 periods. Now you think that how many shells of sodium atoms have is 3, because all the elements are in periods 3. So as all these elements are in period 3, sodium will have 3 shells, magnesium will have 3 shells also, and chlorine will have 3 shells. But the atomic number of sodium is 11 and the atomic number of chlorine is 17. I am thinking about the most left and most right element. So you see that here sodium will have 3 shells and also chlorine will have 3 shells also. But what's the difference? Suppose aluminium will have also 3 shells. Even silicon will have also 3 shells. But the difference is in the atomic number. So as you know that sodium will have 11 electrons, magnesium will have 12 electrons, sulfur will have 16 and chlorine will have 17 electrons. It means it has 17 electrons in the shells and 7 electrons in the outermost shell. If you see silicon, you will have 4 electrons in the outermost shell. If you see aluminium, you will have 3 electrons in the outermost shell. In sodium, you will have only 1 electron in the outermost shell. So what is the difference? So if you go from left to right, you will have more atomic number. So more electrons will be in the shell, but the shell number will be same. So it has 3 shells, it has also 3 shells, but it has 7 electrons which will attract more and which will have the affinity to the nucleus, as because it has 17 protons inside the nucleus and it has 17 electrons in the outer shells, so the attractions between the nucleus, as because nucleus is a positive charged, so proton actually, so when 17 proton will attract 17 electrons from the outermost shell, then the size of the atom will decrease. But here sodium, only 1 electron in the outermost shell. So as it is only 1 electron in the outermost shell, it has only 11 protons, and comparatively in third shell it has 11 protons, it has 11 electrons in outside of the shell. So in the outermost shell of sodium it has only 1 electron. So the attraction of 11 electrons to 11 protons is less than the 17 electrons attractions to the 17 protons. And that is why if you go from left to right, the attraction of these electrons and protons will increase. And that is why if you go from left to right, the atomic radii or atomic radius will decrease. It's because from left to right, the atomic number will increase, so the number of electrons and proton will increase, so the attraction will increase. When attraction increase, the size of the atom will decrease. And if you go from groups from upwards to downwards, if you see the group number 1, you will have like lithium, okay? Suppose I need to erase it. If you see in group number, what's going on? In group number, all elements will have same number of electrons in outermost shell, but when you go down, the shell number will increase. Like in lithium, you will have 2 shells. In sodium, you will have 3 shells. In potassium, you will have 4 shells. Rubidium, it has 5 shells. So you see, in every time when you go downwards, the outermost shell electron number is same. everybody, every elements like hydrogen, it has one electron in outermost shell. Lithium, sodium, potassium, rubidium, cesium, francium, all elements will have one electrons in outermost shell, but the shell number increase when it goes downwards. So when I go from hydrogen to lithium, one shell will increase. When I go from lithium to sodium, another shell will increase. So it means it has 2 shells, 3 shells, 4 shells, 5 shells. When shell number increase, the radius of atom, the atomic radius, is also increase. And that is why the atomic radius is increasing in a group from where we go from upwards to downwards. And you know that this atomic radius is measured by a tiny measurement, that is angstrom, and that 1 angstrom is actually 10 to the power minus 10 meter. So you know that why atomic radius is a periodic properties. If you go from right to left, atomic radius will decrease. If you go in a group from upwards to downwards, atomic radius will increase. And that is why the atomic radius is a periodic properties. If I give you an idea that what are the measurement of these, suppose if I say that this is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and if you go for that, this is lithium, sodium, potassium, rubidium, cesium, francium. Now if you see, the atomic radius of sodium is 2.23 angstrom. But if you see in magnesium, as you know that if I go to right, it will be decreasing, then it is actually 1.82 angstrom. About aluminium, this is 1.72 angstrom. About silicon, this is 1.46 angstrom. About phosphorus, it's about 1.23 angstrom. About sulfur, it's 1.09 angstrom. About chlorine, this is 0.97 angstrom. So you see that gradually it is decreasing. So 2.23, 1.82, 1.72, 1.46, 1.23, like that. So if you go here in this way, that lithium is 2.05 angstrom, here 2.23, here 2.77. If you go in here 2.98, and this is 3.34 angstrom. So you see that when you go downwards, the atomic radius is increasing. When you go from right to left to right, it is decreasing. So now I think you understand that atomic radius is a periodic properties of elements and why it's changing. So thank you so very much. In this video I only discussed till atomic radius, and then in next videos I shall explaining about the electron affinity, electronegativity and ionization's potential of elements as it is a periodic properties. See you on the next class. Stay well, stay blessed. Bye.